Hello guys, assalamu alaikum. Now I will discuss about a problem. The name of the problem is colored balls. So actually what the problem says is there are n different colors, and each different color has AI balls. Like if we name the color is 1, then the color 1 has 1 ball, color 2 has 1 ball, and color 3 has 2 balls. So what you actually need to do is um, um, let's say you can take any of the groups. Sorry, first of all you can take any of the sets, subset from this. Let's say I have taken a subset of 1 and 2. You can take actually 2 and 3. Even you can actually take 1 3 and 1 2 1 2 3. So in all possible subsets you can take, but in one subset, let's say I have taken a subset of this and this. I have made a set of this 1 and 1. So then what, uh, then I can make actually groups. What is group? In groups there can be at most two. In one group there can be at most two balls. Yes, each group should contain at most two balls, and the two balls will be identical in color. One ball is red and another ball cannot be red. It can be any other colors. So I have to say that how many groups, and I have to take the minimum number of groups in one set, in one subset actually. So I have to print that the total number of groups I can build throughout the process. Let's say take this example, then you will understand what the question says better. I can take any of the subsets. Let's say I can take 133 or 137 or 1 this 37 1 this 37 or 17 1337. Any of the subsets I can take. But if I have taken a subset like, um, in this case I will take like all of the elements in one subset, then what I need to do, I need to make groups. Groups means, uh, and I have to take the minimum number of groups. um, so and I have to take the minimum number of groups. And what are the condition of the groups? The groups has at most two elements, at most two balls, and those two balls are identical in color. I'll show it in example. Whiteboard. Let's say I have taken a subset of 1 3 and 3. In this array I can actually take a subset of 1 3 and 3. So what next? um, how many groups I can make with this? I will take a lesser value to make you understand it better. Let's say 1 and 3. If 1 and 3 are present there, then I can take one color from this and another color from this and make a group. So let's say here alls are red and here alls are black. So one red black, and there are too many blacks, but if we take black black, that will not fulfill the condition of making a group. So we'll take black and black separately, because if we take two black black, then this group will have two same color values, which is not the condition of making a group. Here each group contain at most two balls and no more than one balls of each color. So one group can have at most of one group can have a ball of a color at most one time. So there are 1, 2, 3 groups can be made by taking this subset. uh, like this subset, we can take another subset 133, 137, and so on, and we actually need to give the total answer of groups. Okay, let's simulate this to understand it much more better. 1, 1, 2. So how many subsets we can take? Actually 2 to the power 3, that is 8. We can take a subset of just one, this one. We can take subset of just this. We can take subset of this. We can take subset of this and this, means 1, 2. We can take subset of this and this, means again 1, 2. We have taken subset of this, we have taken subset of this. We can take subset of these two, means 1 and 1, and we can take a subset of 1, 1, 2. And another subset is null, meaning that we have taken none of this, so we need not to consider that at all. So if we have taken one color, we can minimum make a group of 1. If this, we can make a minimum group of 1. If this, we can make a minimum group of 2, because these two have the same color, so I need to put them in separate groups. So the minimum number of groups I can make with this subset is actually 2. How many groups we can form here? Minimum groups, um, we can, let's say that is black and this is white, so one black and white can make a group, and remaining another white can make another group. So at minimum there are 2 groups. Here at minimum is 2 groups. Here 1 and 1 can, one white and one black can merge and make one group. This is the minimum. And how many groups, what are the minimum groups from here? Let's say this is white, black and blue. One white and one blue can make a group, and one white and one blue can make another group. So minimum number of groups here from is 2. So we will sum up all of this. 1 plus 1 2, 2 plus 2 4, 4 plus 2 6, 6 plus 2 8, 8 plus 1 9, 9 plus 2 11, and the answer is 11. So we need to print out this. So how can we solve this problem? I will show actually the code. Sorry. Yes. And there is another thing we need to see, that actually the answer may be very large, so we have to take it by modulo this number. Okay, so we have taken a function to mod sum that here the mod value is given, and this add function actually add two numbers and mod them, and this function actually multiplies choose number and mod them. So these are simple functions. Okay, I have taken a vector and taken all these elements in this vector, taken all this into this vector. Okay, and then what I have done, I have actually taken the sum of all values into S. Why I have why I have done this, I will say it next, but I have taken sum of all of this. Then I have done a knapsack dp here. I have done a knapsack dp here. What the dp state actually means, the dp state actually says the here dp of x actually says how many subsets can be made, how many subsets can be made whose elements sum is actually x. So let's say I have 1 1 2 2. So dp of 2 will represent how many subsets are there whose sum value is equals to 2. Here this one can be a subset of sum 2, this is a subset of sum 2, this is a subset of sum 2. So here the dp of 2 means actually 3. There are 3 subsets possible whose sum is 2. Okay, though, so this simple dp state has been made. What it has been done, uh, it has iterated all of the ai value, and then dp j plus I means if I have taken dp of 2, uh, dp of 2, I can actually say that this dp of 2 is nothing but dp of 0 uh, yeah, dp of 0, because if we can make dp of zeros, how many times we can make dp of 0, actually we can make dp of 0, and we have initialized it by 1. So if I have 2, then I can obviously say that how many sorry I can actually say um, dp of how many subsets are there whose sum value is 0 plus some value is 0, and that will add it to its dp2, because I am writing it down again. Dp of not just 2, I will write it like this: dp of x, dp of x is equals to dp of x minus ai, dx minus ai. Okay, it will be plus equals to. Why this? If we somehow can make this, we can obviously add ai, because that is present here. So this all will be added to this. So it is the state, and I have simply write it down backwards. uh, you can see that I have write it backwards. Okay, then what I have done, let's say I can make a sum value equals to 3, subset sum value equals to 3. So how many subsets are present there whose value is 3? I have multiplied it by that value by 2. uh, Here why j plus 1, because if that is odd, then I can handle it down. 5 for 5, that is that will be 3. Okay, added. What that actually means, why I have added like this, let's say I have array of j. Okay, simply j, and these all have the yellow color. Let's say it all have the yellow colors. Then how many subsets have exactly j some value? Let's say there are 3 subsets whose exact value is like j. So I can put actually I can take any of these subsets, I can put any of these subsets. Okay, and let's say there are many groups there, there are many groups there. uh, these um, okay, there are many groups there possible. Okay, okay, okay. sorry, uh, not a pile of same color, that may be of different colors, but j, then I can obviously take half of these. Yes, I can simply take half of these and make groups of them. Have I said it right? Let's see another time. What I have this. Will show an editorial so we can understand it better. Uh, yeah, here there is said. Okay, okay. Oops. Okay. Here it is said, let's iterate over the total number of balls in the set. Okay, increase the answer by j by 2 for each subset of colors with exactly j balls in it. Sorry for taking too much time on explaining. I'll show it again. um, let's say I have a pile of j of same colors, and another I have another subset of the length same j, uh, subset sum of length same j. The subset is like this, you can think of, but the total number of these elements is equals to j. Then what I can do, I can simply group up like this, take one color from ball from this, and take one ball from this, take one ball from this, take one ball from this. In this way I can actually make how many groups? I can actually make j by 2 these many groups. Why? Here for each element, here is a different element possible which is present here, and we can pair it up. We can pair it up. So in such way I can actually make j by 2 groups. Okay. It is said for j of the same color, but what if here are different colors? In this case, that also holds. Let's say here are some different colors. Here are some different colors, and here are the colors, but totally different from this color. So this condition also retains, like that. This is red, but here are no reds. This is yellow, here are no yellow. This is black, here are no black. So this condition also retains. So we will iterate through all possible sum value, all possible subset sum value, and actually multiply j by 2 into dpj. That means here for one, that is j by 2, if we can make this subset let's say 2 more times, that means dp of j is, if dp of j is equals to 3, then we can actually add it with this j by 2 times, j by 2 times, j by 2 times, totally 3 into j by 2 times. So we have multiplied it by dp of j, and what I have multiplied is j by 2. Simply this is j by 2. For odd condition I have added just plus 1. Okay. Yeah. And now comes the last condition. Let's say we have a condition like this. Say okay, where is my whiteboard? Yes, I've said that for the case that if all of the different these colors are not matched with all of these colors, then this holds. But what happens if some colors here, let's say there are two blacks and there are two blacks also, then is this the correct answer? Is this the correct answer? That is obviously no, because we are pairing with a black and a black, a black and a black. That will give us the wrong answer. Here, if there is black and another black, we have to put them out. Put them. We actually add them to another group, so the answer might be greater than this number of groups, because if there is a black, there is a black, let's say, then a group will come where there are two blacks. Then I actually just need to remove this black and add to another black, so the answer would be j plus 2 plus 1. So if there are three blacks, let's say, and sorry, uh, one black, three black, yes, and this plus will how much, let's say this is the dominant color of that subsequent subset actually. So how much we need to actually add? We need to increase this much, because half of them we have increased, half of them we have considered. Again, I need to see a thing.